is D. Sujith Kumar Reddy. I am from VIT Pellu, Tamil Nadu. Today I am going to explain about computer organization architectures Western Electronic 32100 microcontroller. So let's get into the topic. So our first question is draw the clear block diagram of microprocessor or controller selected and give the internal diagram of each block. So here the first half, which is in blue color, is our microprocessor, and this is inside diagram of it. So this is the core. So bus interface, so 32-bit interface is going for addressing, and at another 32-bit is going for data, and 43-bit for interference and control. These are the internal diagrams: microcontroller, executive controller, fetch control, and these operator works as catch and queue. So this is 32-bit registers, working registers and ALU. So addressing arithmetic unit. This is how the process works. So these diagrams can be drawn using online tools. So here I am using uh, creately.com. So let me show you how it will be drawn. So I'm going to just show the first part of this. So how to draw a bus face and another that block in which the bus face is interfacing with addressing data and control. So let me show you that. So let's take a square. Okay, square. You can't expand square in a asymmetric way. So let's take a rectangle. You can place a rectangle here. So you have to drag it down now. So let me show you how it's. So this is how you draw the bus interface, and take another rectangle, drop it here. So this is gonna be of a very small size. So you have to draw it very thin, just barely visible. So okay, let's just increase the size and I'll show you again. So now this is how you have to draw it, bus interface. So let's see. So the bus interface, there are three going. So first one is address, second one is data, and third one is control. So I'm gonna take an arrow. So let's take a small arrow. Okay. So text, it's a 32-bit. Let's draw another line. This line draw this way. So we're gonna name them address, data, and control. So let's take a text bar. Yeah, AD or SS address, data, data, control. So let's select canvas, bus interface, bus, bus interface. So this is how you draw the diagram, and you can continue the diagram by small the size of this and moving towards it. Okay, so let's get into the next question. Uh, the second question is provide an instruction set of microprocessing elements with clock cycle required, mechanic cycles required, and memory required flags affected by the type of instruction based on addressing mode, operation, etc. So these are the sets for Western Electronic 32100. So there are uh, at least more than 100 different type of sets. So each of the set do different operations. So these are the tables of the sets. So you can go through for any specific functions. So the operation codes are here. Okay, and let me skip to the next question. Yeah, the next question is explain microprocessing elements and architecture. Okay, so the Western Electronic 32100 microprocessor performs all the system address generation, control, memory access, and performs functions required in a 32-bit microcomputer system. Execution speed is enhanced by its unique pipeline architecture. So the Western Electronic uses Harvard architecture. So there are two different type of architecture. So we're gonna discuss what is the other type in the next question. So the Harvard architecture is used by Western Electronic 32100. So instruction so using this architecture, the microprocessor overlaps the execution of instructions while tracking each separately. In addition, as each instruction is fetched from memory, it is called in an internal instruction cache, resulting in even greater operation efficiency. The CPU utilizes a combination of address data and stores interface that controls signals to provide the bus protocol required for effective transfer of data. The protocol facilitates interfacing to commercial memories and peripherals, as well as providing wait state generation for handshaking with slow peripherals. In addition, the CPU also provides special coprocessor signals for a high throughput coprocessing environment. So this is the information about RAM. So the memory mode in architecture consists of RAM, ROM, and stack like any other microprocessor. And general purpose register and readable memory is a stable memory in this. So this is partly how one execution per cycle can be achieved. With other microcontroller architectures, this is only one way to access memory, so executions and programming instruction access must be done alternatively. Fourth question, correlate the microprocessing element architecture with architecture discussed in module 1 and 2. So usually two type of architectures are used in microcontroller. One Newman architecture and Harvard architecture. As we discussed, microcontroller, the current using microcontroller, which is electronic, Western Electronic 32100 is using hardware architecture. Uh, von Neumann architecture is used by large percentage of microcontrollers and they are all memory space in same bus and interface and data uses the same bus. In hardware architecture used by most PIC microcontrollers and code and data are separate buses and this allows the code and data to fetch simultaneously results in an improved performance. So here we can see data memory, CPU and program memory. So CPU to program memory. So uh, you can also draw these diagrams using the tool which I was previously showing you. So just go here, folder, create a document. It's a blank document, and you can select uh, squares this time. Square, square, another square, another square. So you can arrows, different types of arrows. So these are two-way side arrows. So here we are using a very small two-way side arrows. So data memory, CPU, program memory. So the first one is data memory, CPU, program memory. Data memory, program memory. So this is how you can draw the diagrams. You can change the size of boxes. You can connect the diagrams and using the shapes and different types of shapes and flowchart instruments, block shapes. You can draw a block diagram. You can take a screenshot or you can download the diagram using the tools provided by this. You have to name this. So you can export it, download as a PNG, JPEG, SVG, and as a PDF. So you can export as PNG. You can download that. Let me show how this. You can change the background settings if you want. If you want to take another JPG image and you can convert it to PNG, you can also do that. So if you want in whichever background you want, you can change that accordingly. So let me continue with the next question. So question number 5. Elaborate register organization in microprocessing element. So the 9 general purpose registers may be used for high speed accumulation, for addressing, or for temporary data storage. The first 3 registers R0, R1, R2 are the microprocessor's scratch registers. These 3 registers are used by C compiler to store temporary value during expression evaluation. They also pass and return specific values during procedure calls. For example, R0 should always be used to return the value of procedure. If the floating point double value is returned for a procedure, it is stored in R0 and R1. If a procedure returns a structure and the pointer to structure should be returned to R2. In addition, the R0, R1, R2 are implicitly used to data transfer instructions movably, strcpy, string copy, and string end, and move version number, interrupt, acknowledge, and enable virtual pin and jump, disable virtual pin and jump, system call, and call process for operating system instructions. So let's go to the sixth question. Explain the types of algorithm used for signed unsigned calculations. So this is how the algorithm works. First, load the data into AX accumulator from memory 3000. Loads the data in BX register from the memory 3002. Multiply BX with accumulator AX. So here are you can see that it was storing in 3000 and 3001, 3002, 3003 accordingly. So move data from AX to memory and move data from DX to AX. Move data from AX to memory and stop. So this is how it works. So first it will store the AX accumulator from the memory of 3000 and loads the data of BX register from memory 3002. So it multiplies BX with accumulator AX. So BX is being multiplied by AX. So the multiplicand, these are the values. Move commands, multiply, mul, move, and HLT. Stop. Microprogram controller units. So go to the fourth question. Find what type of control logic unit used and correlated in the performance with the type of controller unit module in COA syllabus. So the microprogram controller unit, the controller signs associated with the operations are stored in special memory units inaccessible by the programmer as control words. Control signs are designed by a program and are similar to the machine learning programs. And microprogram controller unit is slower in speed because of the time it is taken to fetch macro instructions from the control memory. Some important terms are control word, macro routine, macro instruction, microprogram, and micro control store. So, so this is of the diagram shown. Control store. These are the operation part. Control address, macro instruction registers, and decoders. The DEC1, DECP. So control signal. So micro instruction address register decoder. So the information is passing here from microcontroller program to operation part to decoders and micro instruction register, and the micro instruction register is passing it to the micro instruction address register and decoder. For main memory instruction register, OP code and address, it was also being inserted into micro instruction address generation unit, stated for execution units. So fifth question, explain the memory management system in the processing element selected list in addressing capabilities. Memory mapping technique followed. Find the advantages of the memory design and management techniques over the concepts given in module 4 in the COA syllabus. So the memory management enables the operating system to efficiently manage the memory space for single and multiple processing applications. The memory management concepts are employed with an external memory management unit interface directly to the microprocessor. All operations within the microprocessor are performed on 32-bit quantities, and but data may be read or write as a byte, so half word or a word. So bytes are numbered from right to left, starting at 0, and the right address of the address bus, data bus. The microprocessor automatically extend to byte or half word to 32-bit before performing an operation. Zeros fills the higher order bit for unsigned operations. The signed bit fills the higher order bits for signed operations. See chapter 3 for detailed description for data handling. So a bit field data type is also supported by Western Electronic microprocessor, and the bit field is a sequence of 1 to 32-bit contained in a base word. The field is specified by the address of its base word, a bit offset with a wide. The offset numbers from LSB to the base word and corresponding to the numbers. So this will cover for the next question, and these are the list address modes. So hexagonal number NNN, where n is an hexagonal digit. So AP argument pointer. So these are the few addressing modes. So we have 1 2 3 4 5 6 7 8 9 10 11 and 12 different type of addressing modes are available in Western Electronic 32100 in 32-bit model. So let's go to the next question. Elaborate the pipelining and parallel processing capability of unit and hazard management techniques. So the pipelining in the processor accumulates instructions from the processor to a pipeline. It allows storing and executing instructions in an orderly process. It is also known as pipelining process. Pipelining is a technique where multiple instructions are overlapped during execution. Pipeline is divided into stages. These stages are connected with one to another from a pipe-like structure. Instructions enter from one end to exit from the other end. Pipelining increases the overall instruction throughput. In pipelining system, each segment contains of an input. So we all know the pipelining is that the word will follow the pipeline method. So if the first layer of the data is taken, so the next or forthcoming data will be replaced by it. So in each statement contains of individual. So okay, so Belmac 32 has a pipeline architecture with an instruction fetch unit that serves to control unit to main memory and execute unit which serves to the monitor and process some manipulate data. Belmac 32 hardware was available to store all instructions, data, registers, content associated with the process during a content switch. So this is of the hazard management control. So this diagram is taken from Western Electronic 32100 book, manual book. So this is not drawn in a tool. So this is the most effective to least effective. Physically remove the hazard, replace the hazard, isolate people from the hazard, change the way people work, protect the worker with personal protective equipment. For the 10th question, find whether the processor parallelism is available for the selected element. If does, illustrate cache and protocol types. So so it does not support processor level parallelism from the adhesive very large integration VLSI computer chip fabrication technology in 1970s until 1896 speed up in the computer organization, increase the word size, reduces the number of instructions and processor elements, but so this does not historically 4-bit microprocessors were replaced with 8-bit and then 16-bit then 32-bit microprocessors. This trend generally come to an end with introduction of 32-bit processors which has been standard in the general purpose computer for 2 decades, not until the early 2000s with the advent of 8 into 86 of 64 architectures. The 64-bit processors became commonplace. The catchy corresponding problem coherence: the cache coherence problem in a microprocessor system, data inconsistency may occur among adjacent levels or within the same level of the memory in a memory hierarchy. For example, the cache and main memory may have concurrent copies of the same object. As memory processors operate in parallel and independent, multiple caches may process different copies of same memory block. This create cache coherence problem. So cache coherence schemes help to avoid this problem by maintaining a uniform state for each cache block of data.